So this question asks us, how many atoms are there approximately in one nanoparticle? And a nanoparticle is a combination of a bunch of atoms all stuck together. And nanoparticles, as their name suggests, are on the diameter of 10 nanometers, anywhere from 1 nanometer up to about 100 nanometers. Well, this is another unit conversion problem. It's not completely defined because it just says approximate. It doesn't tell you how big the atoms are. It doesn't tell you what shape the nanoparticle's in. But we're going to approximate. So we're going to make some simple approximations. And the first approximation we're going to make is that our nanoparticle is a cube. Why a cube? Well, because a cube is easier to deal with than a sphere, in my opinion. So this means that my nanoparticle, I know it says it's a diameter of 10 nanometers. It's going to be a cube of 10 nanometers by 10 nanometers by 10 nanometers. This just is going to make the math a little bit quicker, and I'm just looking for an order of magnitude. So I know that the volume of the nanoparticle is equal to 1,000 nanometers cubed. 10 times 10 times 10,000 nanometers cubed. Well, I need to know how big an atom is. And I remember from chemistry that one atom has a diameter of approximately equal to 2.2 nanometers, 2 angstroms. If you remember the unit of angstrom, it's used for, because it's about the size of an atom. So 0.2 nanometers is 2 angstroms. I'm going to go through and figure this out. So I need to figure out how many atoms can I pack into this little cube. So I need to know, if I were to pack all these atoms in, how much volume does one atom take? Well, I know that one atom has a volume of, let's say, another cube, 0.2 nanometers quantity cubed. 0.2 by 0.2 by 0.2, which is going to be 8 times 10 to the minus 3 nanometers cubed. So now I have to figure out how many of these little cubes fit in that. And that's actually pretty easy. I know that this is the volume per atom, and this is the volume per cube. So I want to figure out how many atoms fit in this cube. So I'm going to divide through the volume of the nanoparticle divided by the volume of the atom, which is 10 to the 3 nanometers cubed divided by 8 times 10 to the minus 3 nanometers cubed. And if I actually use all the units that I put down, which were not necessarily a true volume, I'll see that this gives me atoms per cube, or per nanoparticle. So I work this out. I get that this is 10 to the 3. I get another 10 to the 3 from the bottom. 10 to the 3 moves up. 10 to the minus 3 on bottom gives me 10 to the 3 on top. So 10 to the 3, another 10 to the 3. And this 8, that's approximately dividing by 10. So in the end, I get 10 to the 3, 10 to the another 3, for a total of 10 to the 6 on top, 10 to the 1 on bottom. I get about 10 to the 5 atoms per nanoparticle in my cube. So I'm going to say that the correct answer is more than 10,000 atoms. It's closer to around 100,000 atoms. Just an approximation. You get a similar number if you work it out using the volume of a sphere using a diameter of 10 nanometers. It's a radius of 5 nanometers, 4/3 pi r cubed. You can get roughly the same answer, but this is just one quick way of solving it.